Hello everybody, my name is Rishi. Today I'll be solving Deep ML problem number 36. Our task is to calculate accuracy score. Our task is to write a Python function to calculate the accuracy score of a model's predictions. The function should take in two 1D NumPy arrays, yTrue, which contains the true labels, and yPred, which contains the predicted labels. It should return the accuracy score as a float. So, take for this example, where there are 6 elements in yTrue, 6 in yPred. However, in yPred, our third element at index 2 is 0 and not 1. That means we have 5 out of 6 correct. So 5 out of 6 is 0.833333. Yeah, so accuracy score, in simple terms, is equal to the number of predicted elements over the number of correct elements. So there's a simple way we can find that, and we'll be doing that using PyTorch. So do note in PyTorch that inputs may be torch.tensor, list, or numpy.ndArray. So we must convert them to a tensor first. So let's convert them to tensor. So convert inputs to tensor. Y true t for tensor equals torch dot as tensor y true, and then we can just copy paste that and do the exact same for yPred. Okay, now next thing we need to do is find the accuracy score, and there's a couple ways you can do that. The main thing we want to be certain of, though, is that we do it by operating on the entire tensor at once and not by looping through each individual element, because it will take much more time and it'll be much more inefficient on GPU to loop through every single element of a tensor on and on and on and find accuracy cumulatively by looping through, because that means you have to compute the sum of a list that's length n, so then you have O of n time complexity, whereas GPUs can mean you can make this O of 1 time complexity, in fact. So let's find accuracy score and return it. And return it. So accuracy score is equal to the amount of y true values. The amount of y, like the predicted values over the true values that are the correct predicted values of the correct values in total. So in the example, there are 5 corrected predictions out of 6 total. So it's 0.8333. The way we can do this is using a Boolean mask. So this constructs a new tensor that is a data type of torch.bool, and each element of the tensor is a true or a false. And if it's false, it means that yTrue is not equal to yPred for that element. If it's true, that means yTrue is equal to yPred for that element. Now, we need to return a float, so we can dot float this, and true gets turned into 1, false gets turned into 0, or like 1.0 and 0.0. So dot float means we convert it from Boolean data type to a float data type. Let me do dot mean to compress it down to a tensor of just a scalar, and that which is the accuracy score. So dot mean will compute the sum of everything in the tensor divided by the length of the tensor, which then would be our accuracy score, I think. Yeah, because everything that's false, where it's inaccurate, is 0, so it doesn't affect the sum. Everything that's true is 1, so it does affect the sum. So if our accuracy score was 100%, then that means we have true, 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 on and on and on for every single value in the list. If that's true, if that is correct, then that means that we have 1 times the length of the list divided by the length of the list, which gives us 1. So it means that this should work. Hopefully. Okay. So dot mean, and then remember that dot mean is a PyTorch function still, so we need to return a float. So we do this by doing dot item. And now we should be done. Okay, it passes both test cases. You can see passes the first one, that's the example, and the second one, which is 1111 and 1010. Yeah. All right. As always, the code for this will be in the description below. Thank you.